Hi, I'm Mahaz, an AI engineer. Last episode, hierarchical clustering and discant fixed shapes k-means couldn't. But every demo so far had exactly two features, X and Y.
Real datasets don't stop at 2.
50 features, 100. You can't plot that, you only have two eyes.
Episode 25 shows you how to see it anyway.
Principal component analysis. Turns 50 columns into a picture you can actually read. 2 features, you get a scatter plot. Easy.
3 features, a 3D plot. Already harder to read.
10 features, 100. There's no chart for that.
And most of those features are correlated, duplicate information.
PCA finds the few directions that carry almost all the signal. Everything else gets safely dropped.
Picture a cloud of points stretched diagonally.
Rotate a line through the center. At some angle, the points spread out the most. That angle is principal component 1.
The next best direction, perpendicular to it, is principal component 2.
PCA doesn't guess this. It computes it exactly from the covariance matrix. Now drop every point straight onto that PC1 line. Each 2D point becomes one number, its position along PC1.
Compare that to picking a random axis and projecting.
A random axis crushes points together. You lose the separation.
PC1 keeps them spread out. That's the whole point. Each component explains a percentage of the total variance. PC1 might capture 58%. PC2 another 27%. It drops fast after that. Plot it as a bar chart. That's the scree plot. Add a cumulative line. Stop where it crosses 95%.
That tells you exactly how many components to keep.
Take a dataset with 4 features and 3 classes. You can't see it directly. Too many dimensions.
Run PCA down to 2 components. Plot it, and the 3 classes separate into visible clusters.
You never looked at the original 4 columns. PCA did the work. The PCA, fast, linear, and the components are interpretable combinations. t-SNE, better for visualization, but slower and not linear. Feature selection, keeps original columns, easier to explain to stakeholders.
PCA is the default first move for high-dimensional numeric data.
Use t-SNE only when you need a visualization, not a pipeline step. In code, PCA needs one thing first, scaling. Standard scalar, then PCA of n_components equals 2. Fit_transform gives you the projected coordinates. Explained_variance_ratio_ tells you what you kept. If this helped, subscribe. Anomaly detection is next. A few mistakes come up constantly here. Running PCA without scaling first. One big range feature dominates everything. Treating principal components like original features. They're combinations, not columns.
Keeping too few components and losing real signal.
Assuming PCA removes noise, it removes low variance directions, not noise specifically. Using PCA on categorical data without encoding it first. Quick recap. PCA finds directions of maximum variance, in order.
Explain variance ratio tells you how many to keep.
Scale first. Components are combinations, not real features.
It's the fastest way to see data you otherwise couldn't. Episode 26, Anomaly Detection.
Finding the outliers PCA and clustering both step around.
Isolation forest, a completely different way to think about outliers.
Subscribe so you don't miss it.
Challenge task, apply PCA to a high-dimensional dataset of your own.
Scale it, keep 95% variance, plot it in 2D. Solution in the repo. 50 features you couldn't see.
2 components you can read at a glance.
That's not magic. That's variance, sorted. Episode 26, Anomaly Detection, drops next. Subscribe. How many features does your dataset have? Drop it in the comments.